let us now apply all this in practice, and let's start with the discrete case. So, experiment is when we choose a student of our university at random and ask him or her for their grades in calculus and linear algebra. And so they had an exam in calculus, so the grade can be either 2 or 3 or 4 or 5. And as for the linear algebra, there were just a test, so one can pass or not pass, so the grade will be 0 or 1. 0 means not passed, 1 means passed. So let X be a linear algebra grade and Y be calculus grade. And we know the joint distribution of X and Y. So the table of joint distribution is given. So X can be either 0 or 1, and Y can be 2 or 3 or 4 or 5. So, and we know probabilities. Probabilities are 0.2, 0.1, 0.1, 0.05, 0.05, 0.15, 0.15, 0.2. So, what does it mean? It means that a random student with probability 0.2 is the one who got 2 for calculus and 0 for linear algebra. And with probability 0.1, this is one who got 3 for calculus and 0 for linear algebra, and so on. So, or we can interpret this as proportions. So we can say that 20% of all students are those who did not pass neither linear algebra nor calculus, and so on. So after we have this, after we have joint distribution, we can find marginal distributions of X and Y. So we see that X can take values 0 and 1. So for X, the table of its distribution is the table of this kind with 2 columns, as we have 2 possible values. And to find these probabilities, we are to add probabilities from the first row and from the second row of our initial table, of the table of joint distribution. So 0.2 plus 0.1 plus 0.1 plus 0.05 is 0.45. 0.05 plus 0.15 plus 0.15 plus 0.2 is 0.55. So this is marginal distribution of X. Then, as for Y, Y can take 4 possible values. So two, 3, 4, 5. And we do the same thing. We add probabilities, but not by rows, but by columns. So 0.2 plus 0.05 is 0.25. 0.1 plus 0.15, also 0.25. Here also 0.25. And here also the same number. So what does it mean? It means that it is equally likely for a student who is trying to pass a calculus exam to get 2 or 3 or 4 or 5, so approximately 1/4 of all students so has 2, 1/4 3, 1/4 4, and 1/4 5. So now, after we have got the joint distribution and the marginal distributions of x and y, we can check whether they are statistically independent or not. So to do this, we are to check the equality that is a criterion of independence here. So in discrete case, we should check if this probability is equal to the product of these two for all possible values of x and y. So we have 8 pairs of values: 0, 2, 0, 3, 0, 4, 0, 5, 1, 2, 1, 3, 1, 4, 1, 1, 5. So let's start with the first pair. So probability that x is 0 and y is 2. So this probability is 0.2. Then probability that x is 0 is, as we see here, 0.45. And probability that y is 2 is 0.25. And so what do we see? We see that there is no equality here. So 0.45 times 0.25 is not equal to 0.2. So we took the first pair of values and we see that there is no equality for this pair. So that's all. Actually, that means that x and y are not independent. So that there is a statistical dependence between them. So if there were an equality here for this pair of values, for pair 0, 2, what would we do? We would take the next pair, let's say 0, 3, and check if this equality is true for the next pair. And so if it is true for all 8 pairs of values, then, only then, it means that x and y are statistically independent. So if the equality is false, at least for just one pair of values, that means that they are statistically dependent. So after getting this result, we say that x and y are dependent. Now, what about correlation? So the first question that is usually asked, so are these two variables correlated or not? So to answer this question, we are to find their covariance and to check whether it is equal to 0 or not. So formula for covariance is that covariance of x and y is E of xy minus E of x times E of y. As you remember, we usually use not the definition of covariance, but this formula to find it. So, we will need E of x, E of y, and E of the product, E of xy. So, let's start with these two. And this is actually very easy. So, E of x is, according to this table, 0 times 0.45 plus 1 times 0.55. That is 0.55. And E of y is 0.25 plus 3.0.25 plus 4 times 0.25 plus 5 times 0.25. That is equal to, here we have 1/2, here 1.5, here 0.75, this is 2.25, and here 1.25, so this is 3.5. 3.5. Okay, so now we need expected value of x times y. So expected value of the product can be found as follows. So we are to multiply each pair of values by each other and by the probability of these pairs. So 0 times 2 times 0.2 plus 0 times 3 times 0.1 plus 0 times 4 times 0.1 plus 0 times 5 times 0.05 plus 1 times 2 times 0.05 plus 1 times 3 times 0.15 plus 1 times 4 times 0.15 plus 1 times 5 times 0.2. So that is 0.1 plus 0.45, 0.55 plus 0.6, that is 1.05 plus 1. So this is 2.05. So, and now, after we have E of x, E of y, and E of xy, we can find the correlation, the covariance, I'm sorry. So, this is 2.05 minus 0.55 times 3.5, and this is equal to 0.125 or 1/8. So we see that covariance is not equal to 0. So as covariance is not 0, then this means that x and y are correlated. By the way, as you remember, if two variables are independent, then they are uncorrelated. So if x and y were independent, so if after checking them for independence, if we found that they are independent, so there would be no need for calculating this. So independence automatically means covariance equal to 0. So, but they appear to be dependent, so that is why, to answer the question about their correlation, we are to calculate all this. So now we know that x and y are correlated. So we know that there is a kind of a linear statistical dependence between them, but we don't know the strength of this dependence. So to know how strong the correlation is, we are to find the correlation coefficient of this pair of variables. So we already know that the formula for the correlation coefficient. So this is covariance divided by the square root of the product of their variances. So we have already got the covariance. We have just found it, and it is equal to 0.125. And so now we need variances of x and y. To find variances, we should start with expected value of squared x and squared y. So expected value of x squared is 0 squared times 0.45 plus 1 squared times 0.55, that is 0.55. Then variance of x is expected value of x squared minus squared expected value of x, that is 0.55 minus 0.55 squared, that is 0.2475. Now let's go to y. So e of y squared is 2 squared times 0.25 plus 3 squared times 0.25 plus 4 squared times 0.25 plus 5 squared times 0.25. And if we do all necessary calculations, we will see that this is equal to 13.5. So then variance of y is e of y squared minus squared e of y. This is 13.5 minus 3.5 squared, and this is equal to 1.25. So now we have the covariance of x and y, the variance of x, and the variance of y, and we are ready to substitute these three values to the formula of the correlation. So this is 0.125 divided by square root of 0.2475 times 1.25. So if we do calculations we need to do, we will get approximately 0.225. So this number has its own physical meaning. So this number shows us how strong the linear dependence between linear algebra grade and calculus grade is. So it is positive, so it means it is not zero, it is positive. So this means that there is a positive dependence that is actually we can imagine that this should be true even by our intuition. So if the one has good grades in calculus, probably this student also has good grades in linear algebra. So there must be some positive correlation, and we see that there is, but we see that it is not so very strong. So this coefficient is closer to 0 than to 1. So that means that there is a positive correlation, but slight positive correlation, we can say so.